Okay, question number 2. A particle moving along a curve in the xy plane has position xt, yt at time t seconds, where xt and yt are measured in centimeters. It is known that x prime t equals this and y prime t equals this. At time t equals 2, the particle is at the point 36. Okay, so question number A. Find the speed of the particle at time t equals 2. So the speed of the particle. We were given x prime t and y prime t. So the speed of the particle is the equation. Okay, speed equals square root of dx dt squared plus dy dt squared. Okay, and we want to find the speed at time t equals 2, so we substitute t equals 2 into these two values. Okay, so let's write that down. Dx dt is basically x prime t, so at minus t squared plus dy dt is y prime t, so we put that here. And squared, remember the squared. And then the entire thing square root. Okay, so at t equals 2, at t equals 2 seconds, the speed is equals to, but we should substitute t equals 2 into these t's. Okay. Okay, and using a calculator we can find that the value is 12.305. Okay, and there's no there are units here, so the speed is in centimeters per second. Okay, t equals 2 seconds, so the time unit is seconds. The distance unit is in centimeters, so it's cm per second. Okay. Part B of the question, find the total distance traveled by the particle over time t equals 0 to t equals 2. And show the setup for calculations. Total distance formula. The distance formula is the integral from a to b, so in this case it's 0 to 2, and we have this speed equation here. So the total distance equation is the integral from a to b over this time interval here, plus within the speed function. Okay, so it's from 0 to 2, and this function. Alright, so if you write this down, we can just use the calculator to find out the answer, which is 15.902. Okay. Okay, part C. Find the y-coordinate of the position of the particle at time t equals 0. Show the setup for calculations. so with these problems, it is using the fundamental theorem of calculus. So we were given at time t equals 2 seconds the particles at the point 3 and 6. Okay, so we can write it like this. Well, we were being asked to find the y coordinate at t equals 0. So the y coordinate, y0, we asked to find y0, and we were given that y2 at 2 seconds equals 6 centimeters. Okay, so the fundamental theorem of calculus states that y2 minus y0 equals from t equals 0 to t equals 2 y prime t dt. So we are asked to find y0, so let's rearrange this. y2 minus 0 to 2 y prime dt equals y0. Okay, so we were given the values y2, it is equal to 6, and y prime t is also given, it is this function right over here. So 0 over 2, we just substitute this in. y0 equals this thing, and we can find this value by using a calculator. We'll find that it is equals to negative 1.174. Okay, and question number D, for t equals 2 to t equals 8, the particle remains in the first quadrant. So reminder is that the first quadrant is here. This is the first quadrant. This is the second, third, and fourth. So we're from t equals 2 to t equals 8, the particle remains here. Find all times t in the interval t equals 2 to t equals 8 when the particle is moving toward the x-axis. So moving towards the x-axis means this is the x, this is the y. Moving towards means that something like this, anywhere in the first quadrant, which means that the y coordinate is decreasing. So we can say that when y prime t is negative, which is this, then the particle is moving towards the x-axis. Okay, so if we find y prime t equals 0 first, y prime t equals 0, which is this function. Then t would equals to 5.222. And we're talking about the intervals from t equals 2 to t equals 8. So there are two possible intervals that y prime t is less than 0. So the intervals are 2 to 5.222 and 5.222. Wait, 2, okay, to 8. So let's plug a random value within these two intervals and see which one is smaller than 0. So 3, if we plug that in, let's see, a random value, 3, which will equals to Yeah. So this value will be greater than 0, so this is not smaller than 0. So y prime t with these values is not smaller than 0. It is greater than 0. And so this interval should be smaller than 0. Okay, so this is smaller than 0. So within the intervals 5, 2, 2, 2, t to 8, the particle will be moving to the x-axis, because y prime t is smaller than 0 when 5.22 between 5.22 and t equals 8.